Now let's look into one more Kubernetes object, that is deployment object, which is widely used by DevOps guys or DevOps tools. So deployment is one of the most used object by us or DevOps guys or tools which are involved in DevOps. If you see that the most of the DevOps work is involved around deployments, making changes, making regular changes to the application, to the code, and by using deployment object, you can upgrade your apps, upgrade your pod images, basically roll back something goes wrong and it's going to be gracefully in a rolling fashion. So by definition, it says deployment controller provides declarative updates. You declare it in a definition file for pods and a replica set. So deployment uses a replica set. A replica set we have seen in the previous lecture. It makes changes to your pod or it maintains the replica of your pod. So you give a definition of deployment. This in turn creates a replica set and replica set will maintain your pod. And when you want, you can make changes. So you can define the desired state. So I want this particular way of happening in our DevOps so that we can handle Kubernetes, we can handle our containers or applications using Kubernetes pretty well. So now we will see few more concepts of deployments object. So deployment provides declarative updates for pods and replicas, replica sets. You describe a desired state in a deployment and the deployment controller changes the actual state to the desired state at a controlled rate. That also we are gonna see. You can define deployments to create a new replica sets or to remove existing deployments and adopt all their resources with the new deployments. So now let's look into some of the use cases of deployments. The following are the typical use cases for deployments. The first one is create a deployment to roll out a replica set. The replica set creates pods in the background. Check the status of the rollout to see if it succeeds or not. And second use case is declare the new state of the pods by updating the pod template spec of the deployment. A new replica set is created and the deployment manages moving the pods from the old replica set to the new one at a controlled rate. So each new replica set updates the revision of the deployment. So this is also we are going to do. So each use case we are going to demonstrate here. So first one is create a deployment to roll out a replica set. That is one. And second one is declare the new state of the pods. Okay, that also will do. Now, and the third one we have is roll back to an earlier deployment revision. That also will do. So if the current state of the deployment is not stable, so each rollback updates the revision of the deployment. And we have a few more scale up the deployment to facilitate more load that we can do. That's not a big deal. And pause the rollout of a deployment to apply multiple fixes to its pod template spec and then resume it to start a new rollout. Then we have a few more. That's a clean up older replica set. So, and you don't need any more. If you want, you can clean up. If you don't need any more, all the pods and replica sets, you can completely clean up. That's using delete. And use the status of the deployment as an indicator that rollout as rollout as stuck. So now let's look into one example, creating a deployment. The following is an example of a deployment. It creates a replica set to bring up 3 Nginx pods. You can see that on the screen. A deployment named Nginx. This is the deployment object, and the name of this deployment object is Nginx deployment. Okay. Now, in this Nginx deployment, what all things is going to be is going to happen. The first one, in this deployment, a deployment named Nginx deployment is created when you using a command kubectl apply f option, and then if you give this deployment.aml file, so the uh, Nginx deployment will be created. So this will become the basis for replica sets and pods which are created later. So this consists of for the following information. So Nginx deployment is our deployment, and the labels is app Nginx, and 3 replicas. So replica set is Nginx. I think replica set is Nginx. You see that, and template is Nginx, and spec. So here we have our image. It's 1.14.2, and then container port mapping is 80. So now when we say kubectl apply, it will get applied, and when we run a kubectl get deployment, we'll get the deployments. And when we say kubectl rollout status deployment, the output the waiting for the rollout. So the deployment will be rolled out. If you want to roll back, you can give roll out, or you can roll back also. Okay, so now let's get into the action. By to wait more. So what will we do is we will enter into our server. That's a cops VM. Where it is, yeah, here it is. Clear this, clear the screen. Sudo option I cd root defs ls. So here I'm going to create a directory saying dip defs. I think it's there. Yeah, first one def cd def and ls. We have one. So this time I'm going to create one more directory. That's Nginx. mkdir Nginx dep and cd Nginx dep. So inside that I'm going to create a deployment.aml file. So vim deployment.aml file. So let's write this file on VS Code. So let me deployment.aml file, and kind it's deployment. Yes, our template is ready. So now it's easy. So kind deployment metadata name, I'm gonna give the deployment metadata. It's the deployment name it's asking. The name of the deployment I'm gonna give Nginx, and it's Nginx deployment. That's fine. Then spec. So now in spec I have selector. So at this moment, but before that, I want to attach a replicas. It doesn't have a replicas object. So inside the spec, immediately I'm going to attach the a replica set. So replica, how much you like to have? Okay, metadata and name is done. I will add a labels also here. App Nginx. Yeah. So now spec. So replicas 3 is fine, and selector, so we want to match the labels. So what's the label that we have taken? That's app nginx. So then we had template, metadata, again labels app, this time also it's nginx. Then one more spec, it's indented, a nested spec inside the template. So this consists of a containers data. So let me add the containers data here. So name of the container, I'm gonna give nginx, and image I will fetch it from nginx, I think, yeah, version 1. Yes, no, yeah, this is fine. Version 1, nginx version 1. Then resources is not required. The only thing I can have is port. That's it, that's more than enough. Let me remove this. Yeah, ports and container port is 80. That's it. Rest all fine. Now this is our deployment definition file. So let's get into the server. That's a COPS machine and paste it. So our deployment definition file is ready. Now it's time to create our first deployment. First ever deployment. So kubectl, I'll say apply, option F, and okay, before that let's delete any container with that name or pods with that name. So kubectl get pod, kubectl delete pod nginx f, nginx f has been deleted. Now we have nginx dep. Let me copy. Okay, if we delete all those, so okay, specifically nginx is not there, so that's okay. So let's create deploy. So kubectl apply, option F, and deployment.aml. So the deployment dot apps / nginx deployment has been created. So that's what, if you remember, that's what the name we have given, and nginx deployment. So now let's say kubectl get deploy. So this will give you all the deployments that we have. So we have two deployments. One deployment we have done earlier, that is 6 hours 18 minutes ago. That's nginx dep, but this time the name that we have given is nginx deployment, just 30 seconds ago. Okay, so now let's do kubectl get replica sets. You see that your nginx deployment, this is our replica set. You can see all three. That means it doesn't mean 3 plus 3 plus 9. No, not at all. So we have desired 3 and we have desired 3 pods. So current 3 pods and ready 3 pods. So the status is absolutely fine. We have desired for 3 and the current state is also 3. So hence 3 are also ready. So that's fantastic. So all are successfully executed. 3, 3, 3 each. So now let's also see kubectl get pod. And you see that we have our nginx deployment here just 2 minutes ago. So with this, the benefit of deployment object is with the one definition file, you are able to create a replica sets, and you are also able to create pods. You don't need to specifically create a pod. You can create pods and their replica sets using one file called deployment. Deployment. Once you deploy your pods using with the replica sets, then you can create your services. Then that services can make your application communicate with make your pods communicate with each other and make your overall application accessible to external user or outside network. So that's the main objects. These are objects which we widely use. So then so everything will get so once that is done, now let's describe a specific pod, or else we can also describe uh, deploy or rs replica set. Let's do kubectl. Okay, I'm not describe, I'll go with describe. Describe its pod and its nginx deployment, anything we can take. Yeah, yeah, here you should see. So successfully assigned default nginx, so container image name. So created container nginx and started container nginx. So at this moment a container is successfully spinning. Let's look into the image name. I hope we'll find it. Yeah, here it is. This is the image name that we are using. So this time what we are going to do is we are going to change the image name and we will run it again. Okay. So for that, or else we can do the similar thing, kubectl describe. Let me kubectl get. This time it's a deploy, and these are the 3. So kubectl describe deploy nginx deployment. And here you should see this is our deployment description. So type normal, scaling replica set, of course, age is 4 minutes 50 seconds, and from deployment controller, scale up replica set nginx. So 2 3. So how many? 3. Rest all it's fine. Nginx deployment ID and row desired is desired, updated, unavailable. So that's what. Now let's also do kubectl get it's rs a replica set. We have 2 replica sets. So kubectl describe rs, that's our replica set, and this is our replica set object, and execute. Here we should see, so total a replica set controller into action, and 3 has been created, the first one, second one, and third one. And this is the image. This is our container, a clear-cut information about the pod template. This is the pod template information. You can see that labels is Nginx label, and containers, it's a name of the container is Nginx. Inside that image you are using is kubectl Nginx version 1, and then a port is 80 TCP. Okay, this is what we want to change. We will do the change to this, and we will rerun that. But before that, if you want to roll back to the previous replica set, rolling back to the previous revision is also possible. But for that, before that, let's see the replica sets. It's kubectl get rs. So we have two replica sets here, Nginx dep and Nginx deployment. Let me try to do that. Of course, these are two different kubectl rollout. These are all of not the same file. So that's the reason. What will we do is we will do a small modification to our file, and then we will create one more deployment. So what we're gonna do is first we'll do it imperatively. So for that, Nginx is the container name, and update the container with the latest version directly. Okay. So what I'll do is kubectl set image deployment dot v1 dot apps / Nginx and deployment. So here name of the container is Nginx, and image I am gonna say Nginx latest. That's it. And let me execute it. So there is the unknown command images deployment. That's okay. Let's directly so in spite of try to solving this okay, it's image. Where is that? Kubectl set, and that's image, not images, but that's okay. It's imperative way. I don't advise you to do this imperative way. Okay, it's done. Anyway, I don't advise you to do this imperative way. So Nginx deployment image updated with the new image, and let me check. Let me clear the screen and say kubectl get rs, and here it is. One more has been created, and the old one has been completely gone. So this is the 9 minutes ago, 53 seconds it's gone, and this is the new rollout. This is new update. The old one has been gone. The new one has been updated with 333, with the 3 pods. So now let's also see the kubectl get deploy, and you see that the deployment Nginx just 10 minutes ago, whatever is there, it's proper, no issue with it. So now what we're gonna do is kubectl will describe that deployment, and then we'll describe the specific deployment object. Then kubectl describe, and then pod. Let me get the pods first. kubectl get pod, just to see the new image. That's it. We have updated with the new image. Let's look into the new image, or else we'll do it using rs only. You don't need to use specific, so I'll use rs. So kubectl, and it's describe, and it's rs replica set, and the name of the replica set, here is the replica set. This is the old one. Let me go with the new one. This is the new one. Let me check it. Yes, yeah, you could see that. A pod templates, app nginx container. You see nginx container. Image is nginx latest. This is nginx latest, the old one. Nginx latest. The new one is nginx latest, whereas the old one is kubectl nginx version 1. So that's how you can update. I'll show you that. So we have done create a deployment to roll out a replica set. That's the first activity we have done. We have rolled out three replicas of our pod. Okay, and the second one, declare the new state of the pods. Just now we have done it. We have declared the new state of the pod. So I'll show you that also again. kubectl get deploy, and you see that this is nginx deployment. This is a new state. This is absolutely new state. To cross check whether it is new or old, you can use a specific command. But before that, what we are going to do is we are going to undo the deployment. Undo the deployment back to the role. Okay, let's create one more deployment file. So that's the imperative way. We have done it imperative way. This time we are going to create nginx one more deployment. So let me clear the screen first, and let me do vim deployment.ml, and I'm going to change it here also. Directly changing. We have done it imperatively before. Now we are going to do it declaratively. So latest, and I will remove this too. Yeah, and then save. Let me run it. kubectl apply option F deployment.ml. So the new deployment.apps nginx deployment has been configured. It's been configured. Now kubectl get deploy. Sorry, you see that nginx deployment has been configured. Now let me check the kubectl get rs, and this is what 5 minutes 24 and then 14 minutes. Now what I'm gonna do is I want to roll back this status. I want to roll back this, whatever the previous one. I just want to I just want to have that deployment only, not the latest one. Okay, for this is what we call it as a rolling back. So let's roll back to the previous replica set. So rolling back to the previous revision, that's what we are going to do. So for that, I will say kubectl rollout undo, then deployment. So this is what the deployment and nginx deployment. That's what the name we have given. I think nginx deployment. Nginx deployment. So the rollback has been done. It's successful. You see that nginx deployment rolled back. Now let me cross check that. kubectl get rs, and you see that magic. So this is the world one, and and all the pods have been moved to the world deployment, world nginx replica set, and new replica set has been gone. 6 minutes 48 seconds. This is the latest one. Latest one is no more in use, and the oldest one is in use. That's how we can roll back. So with this, we have seen the third. With this, we have seen the third use case, a roll back to an earlier deployment revision. So now let me say kubectl get pods, and here are those pods. So all pods are just 68 seconds, 66 seconds, 67 seconds, because we have rolled back. We have rolled back. That's the reason. Now what will we do is we will have more fun. This time I'm gonna, okay, first we will cross check the image, and after cross checking that, we will have one more version. So kubectl describe, I will use rs. So nginx, this is a new one now. This is a old one, recently rolled back to the old one. So I'm gonna give that describe rs. Yeah, all fine. And these are the events that had happened. Let me scroll up to find out the image name. Yes, yes, you see that the container and the image name is kubechurn nginx v1. This is how you can roll back, and this is how you can use your deployment to get the maximum benefit out of the Kubernetes. So let me give kubectl get pods, and you see these are all recent ones. These are not too far. These are the recent ones. If we do the roll back again, then it will be shifted to others. So roll back kubectl get kubectl roll to roll back to the nginx deployment. So nginx deployment rolled back. Now let me say kubectl get pods. You see that just a few seconds before the pods has been started. That's what, whenever you deploy, it will begin newly. Whenever you deploy, it will just start a fresh pods. That's what I want to tell you. And now let's see the kubectl get rs also. And now you could see again it has rolled back to the earlier one. That's the 10 minutes before one. We have two, right? This is the first one, nginx deployment cd one is the first one, and this is the later one. Now we have rolled back to the later one. So now let's we can also give kubectl rollout history to see how many times we rolled out. So deployment nginx and deployment. You see that revision, change costs, and 3 4. So this is how you will get the complete revision history, rollout history and rollout revision history. So now finally let me say kubectl get deploy, and we have two deployments at this moment. So let me get back. So this is how we use deployment. So the deployment is nothing but it's deploying a replica set and pods together. So the benefits that we can get uh, out of this is we can roll out, we can update, we can get a desired state, and we can also pause the rollout of a deployment. You can clean up the complete replication replica sets also. Basically we will have a flexibility to handle, because if you directly handle with a pod, it's not that easy. So if you handle with the deployment, so deployment can easily tackle both the replica sets and then pods objects in our Kubernetes.